Cool. All right. Hey, everybody. Welcome to phase 3. Before I get started, a couple things to note. First, don't forget to schedule your project review with me. I think about a little more than half of you have scheduled your review with me. So you do have until next Friday to pass the review, but I do think the earlier the better, just because we're going to be getting into some really deep machine learning stuff, and I don't want there to be too much overlap between the different phases. So the sooner the better. As you know from the last time, my reviews are pretty chill. If there's anything that's missing, I'll make you a bullet point list of things that you need to hit anyways. So low pressure, let's just get that review in. Here I have a preview of this week's material, which I'll talk about in a little bit as well. Also, don't forget to submit your projects the day before your review. I already have a few submissions in, so thank you for those of you who have submitted. And also, lastly, your second blog post. Everyone has submitted their first blog post, so thank you for doing that. But your second blog post is due before the next project begins, so let's aim for finishing that by the end of next week as well. Again, I have linked to the sample blogs over here, like Flatiron blog examples. But most people like to write their blog on the project that they just did. So if you have anything that you want to write about regarding regression, feel free to do that. If not, any data science topic works as well. And if you have any questions about that, you can let me know. But yeah, I think those are the main things to touch. Questions about any of that? Okay, I do want to give everyone a really quick overview of what phase 3 is going to look like. So out of the 3 weeks of phase 3 material, this week we're doing topics 21 through 24. And I like to characterize this as like tying up a lot of loose ends that we had at the end of phase 2. I know that we got into linear regression super quick after a lot of like stats theory stuff. So topics 21 through 24 will kind of go under the hood of what we were actually doing with linear regression. Object-oriented programming, which we're going to talk about today, so I won't talk about that right now, but linear algebra and calculus are the two math concepts or two math topics that make up gradient descent. And it's basically how your model was able to figure out what the best coefficients were, how any model works actually. So we're going to talk about that. Topic 24, if you remember, I talked about overfitting and like the bias variance trade-off. So topic 24 is going to be an extension on our linear models in the sense that ridge and lasso are different models that we can use in place of a linear regression that actually take into account overfitting. So that's what we'll talk about on Friday. So excited to get into that. Now, after this week, the 2 weeks that follow that is going to be pretty intense. Topics 25 all the way through 32, pretty much every day we're learning a new model. Linear regression was one model that we spent a week on, but for these topics, every day is going to be a new model. So it's going to be pretty intense. I'm going to set up some activities for you all, just so it can make it a little easier to digest. Part of those activities will involve you creating functions to make doing your project later easier as well. So just a heads up. Another reason why I do recommend getting your project reviews done sooner rather than later. For the project, for the phase 3 project, I'm going to give you all a choice as well on whether you want to work on it in a pair or individually. Also, you will have the opportunity to choose your own data set. We don't have to look at the project yet. I would say I'm going to go through some overall things to look out for the project next week. But just a heads up, I will be giving you all the choice whether you want to do it individually or in a pair again. So just know that that's coming up as well. Cool. So it's gonna be a pretty intense phase, but I will tell you this is my favorite phase. It's a phase that made me fall in love with data science. I'm really excited to get into it. Before we start, anyone have any like questions on any of those like housekeeping things I talked about? Ooh, also in the Slack channel, Amber posted a link to the survey. If you could fill out the end of phase survey for me, that'd be really awesome. All right. Without further ado, let's get into object-oriented programming. So with this topic, we're going to take a little bit of a step back. So object-oriented programming is kind of what we've been already doing, kind of, because everything in Python is objects. So what we're going to do today is we're going to kind of take a step back and uncover what it is we've been doing all this time. And I think through today's topic, it will kind of illuminate and uncover what we were doing with, like, every time we use a method or every time we use a function. What does that mean and what is that doing in theory? Everything in Python is an object. Python is known as an object-oriented language, but we really haven't talked about those objects yet. If you remember when we were doing things like map functions or filter functions, sometimes the output doesn't come out and it comes out in that like map object at whatever address. Those are all objects, and we're going to kind of talk about that and what those are really. So so far, we've learned how to create objects from built-in classes provided by Python. So pretty much everything, integers, strings, lists, these are all objects as well. And we've been learning how to organize these into functions that can process and manipulate data. Pretty much everything that we're doing in pandas even. These are all methods that are pre-built with classes and objects. And so, yeah. So that process of using functions is known as procedural programming. And another type of programming, which, to be honest, data scientists don't use directly as much, is object-oriented programming. So that's the two ways. But procedural programming does use elements of object-oriented programming. Okay, so to start, just some terminology. And we're going to use the analogy of a person. So few terms, there is class, objects, properties, and methods. So the class in this example, human, is a class. And the object within a class is a specific human being. And so therefore it can be identified using the name. Now, for any object, it has a set of properties and a set of methods. This is also quite similar to when in pandas, we were talking about the difference between an attribute and a method, kind of the same thing. So properties of a person, maybe you have their email, their address, any information about the person. And also every object has methods, any kind of action that it can take. For example, it can verify things, it can send mail, it can talk to someone. So there's a distinction between properties and methods. Now, if you remember from pandas, anything that's a property doesn't have parentheses at the end of the method or attribute. And if it's a method, it will have parentheses at the end of it. So that's how you distinguish between an attribute or a property and a method. All right, so if we go back to the idea of what a function does, a function is an abstraction whereby an algorithm is made repeatable. So instead of coding a number squared plus 10 over and over again, like this with 3 print statements, or even doing it in a for loop, we write a function so that we can do this even faster, right? We can just do square add 10, and that just makes it a little bit easier. So now we imagine a further abstraction. So before, we were creating a function that was about making a certain algorithm, this algorithm, available to different inputs. Let's say you want to make this function available to different objects. So an object is what we get out of this further abstraction. And each object is an instance of a class that will define a bunch of attributes and methods. And we're actually going to go through an example of making objects, and we'll kind of show how these attributes and methods are pre-built into everything. So every object of a class will automatically have those proprietary attributes and methods. So if you remember when we were doing our scikit-learn linear regression, there was one line that we did like linreg equal to linear regression with parentheses. That is known as instantiation. So the idea here is when you do this step of every object of the class will automatically have proprietary attributes and methods, that's what we're doing. What we did in that line was we created a linear regression object. And so we'll go into slightly simpler examples in that in a little bit. Okay, so when we say everything in Python is an object, we really mean that everything is an object. All attributes, methods of objects are themselves objects with their own information. So let's say x equal to 3. So x is an integer of 3. Now, by doing this, we're doing not just x equal to 3, but we're also imbuing x with the attributes of the integer class. So x is an object that is of the integer class. So X now also has methods, basically the tasks that integers can do of the integer class. And often methods provide a way to modify the attributes of an object. So as an example, one of the methods that you can get out of an integer that we actually don't use so much, but just good to know that there are methods pre-built, is bit length. So when I run this, the bit length of X is 2. If I rerun this with X being this other number, the bit length of X is now 25. So bit length is actually a method of integers that are already pre-built into any integer object. Questions about that? Cool. So basically, to summarize, an object is an entity that contains data with associated metadata and or functionality. So in this case, the metadata would be attributes, functionality, methods. So in Python, every entity has some metadata and some associated functionality. And so these attributes and methods are accessed, as we know, through the dot syntax. So every time we need to use a dot, every time we need to use an attribute, we just do dot attribute. Every time we want to use a method, dot the method with parentheses. So this is another analogy that we can use. Think of the use of objects and classes like a blueprint. So let's just say we have a car class, but we want to make a bunch of different cars. Let's say every car has a name, a color, I don't know, miles per gallon. When you instantiate a car, you can give it properties like this. So let's just go through an example that we're going to code out. If anyone has ever taken some sort of intro to Python course, you likely would have seen the creation of classes again. I'll tell you that in data science, we don't manually create classes very often, but you can. Sometimes it provides a more efficient way to store and organize your functions. But it's not something that, as data scientists, to be honest, it's not something that we do very often. But it's good to know how code is structured. And that's why this is important for us to learn. So what we're going to do is we're going to create a robot class, and we're going to build up this robot class to be a little bit more complex over the course of this notebook. But this will show how properties and functionalities are automatically imbued to every robot in a robot class. Okay, so some syntax things. When you want to create a new class of objects, or you want to create the blueprint of a new class of objects, you start with class. In a very similar way you define like a function with def, def, we are going to use class. And also the naming convention, if you're creating a class, it's always upper camel case. Now, camel case is because every new word has a capital letter. So you can see like these C's are capital letters, and that it's called camel case because of like the humps on a camel. And upper camel case just says that the first letter is also capitalized. Lower camel case would be like this: DS lower camel case. So just some good things to know. And right now we will use a blank template. So right now we won't have any predetermined attributes or methods for a robot. So we're defining a robot to be really just nothing, just a robot object that is empty to start. And this is what that is, just pass, but does nothing. So what we're going to do is we're going to create 2 robots. So what we've done here is we've instantiated 2 robots, one under my robot, one under your robot. So this syntax looks very, very familiar to us because our scikit-learn linear regression, when we did that, this step is known as instantiation. So instantiation. So for a blank, for a empty object, you can actually give it whatever attribute you want. And what we've done here is we've given the robots names and heights. Oops, what did I just do? Okay. So my robot's going to be named Wally and has a height of 100 centimeters. Your robot is going to have the name Bob and have a height of 200 centimeters. So even though they were both instantiated from the robot class, you can give them their own unique features. And from here, we're just going to print out these attributes. So here, there's Wally with height 100, Bob with height 200. And because we've saved these attributes, we can pull them out. So I can look at my robot dot name. We have Wally. If we look at dot height, we have 100. You can do the same for Bob as well. So you can add as many attributes as you want. So for example, here, we didn't give it a purpose. So at this point, our robots have no purpose. So when we try and print a purpose, the robot has no attribute purpose. So all we have to do is add that in. A couple ways to do this. If you want just a specific robot to have this purpose, you can do my robot.purpose equal to, and let's just use this one, to always protect humans. So we set this as its purpose. Now it has a purpose. So what if we want all our robots to have the same purpose? This is where we are imbuing every instantiated object with the same property. So here, under class robot, we're just going to add a line that says purpose equal to always protect humans. So here, we'll reinstantiate our robot class and give it life again. So this is exactly the same code as we had before, but now let's just set a new one so we know that it's a different one. So let's do this robot equals to robot. And actually at this point, this robot doesn't have a name or a height. However, this robot has a purpose to always protect humans. So because we recreated this class and reinstantiated these two objects here, both and all three of these robots will have this default purpose to always protect humans. So that's how we define default attributes to this robot. Questions at this point?
Is there a way to see all of the attributes that you have assigned to a particular instance, like a particular object?
Yeah, there is. I don't know it off. I think it's dot attributes. Let's see. Something like that. I don't know it off the top of my head. Okay. But there is a method that's built in that can look at all the attributes of an object.
Okay, and that happens because that's like a property of how classes work in Python?
Mm-hmm.
Okay.
Yeah. Mm-hmm. Yeah, because in this object, and as you can see here, this is I feel like some of you might have come across this kind of syntax for other objects as well. But if we were to just output this object, it's not something that, it's not a tangible output. This is basically saying that there is a robot object at this address stored in your computer's memory. So because it is being stored like that, all the attributes of any object are also stored in this address.
So it's like a container, and you can't see what's inside the container, and you can only tell, like, ask for things out of it.
Yeah, exactly. So I can do, right now, it doesn't have a name yet, but yeah, any of the attributes you can pull out from there. Let me see if I can just Google it really quickly. Python see all attributes of an object. Cool. So it is, let's see. Is it .keys? Oh, I think it's .dict. No, bars. I don't remember what it is, but there is definitely a way to do it. Get members. Let's see. Let's find out. Okay, I have to look into it more. But yeah, there is definitely a way to see all attributes.
Okay, cool.
Awesome. All right, so here, that robot also has a purpose. Cool. So all of these attributes are can be overwritten. So none of these are, what's the word? They're immutable, basically. You can overwrite robot, you can overwrite object attributes whenever you want. So even though we are instantiating this evil robot as also in as part of the same class, you can overwrite its purpose to kill all humans in this case. So we print this out. You can see that the evil robot's purpose is to kill all humans because we overwrote the protect humans purpose to kill all humans here. So attributes can be overwritten. Cool. So what can we also do? We can also compare a lot of different things. You can use objects pretty much like where you can use attributes of an object as the same way you would use any sort of data used in Python. So for example, if you want to compare the heights of robots, you can just use the value that is stored in their attributes. So you can use it for computation. You can run for loops on different objects. If you have like a list of objects, you can do all of that. Cool. So if you want to look in memory, I think I talked about this. Yeah, I talked about this a couple cells ago. This is the hash symbol of where in your computer's memory this object is being stored. And then also, are they the same? So different objects are not equivalent to each other. So these are new objects that are being created. Every time you instantiate something new or a new object, even though it's from the same class, they are distinct. They are distinct objects stored in different parts of memory. So here you can see, are they equal? They're not equal. Are they the same? They're not the same. And are you yourself? Yes, it is. Cool. Okay, so we talked about default attributes at the very start. Default attributes, we talked about having a default purpose to always protect humans. So we can kind of expand that a little bit more. So first, let's just say that all robots are going to have some name. They have a material that is by default metal. They are electric and have 2 arms. So let's just say that these are our default attributes of robots, and let's recreate this class. So for this robot number 1, we have these attributes to start. Again, because attributes can be overwritten, we can change its name, we can add a new attribute that is solar, and we can see that these are automatically updated. Same thing, very similar as to when you want to like edit a single element in a list. All overwritable, and you can add as many attributes as you want to an object. Although I know that in some libraries, there is code in place to stop you from randomly adding attributes to objects that shouldn't have additional attributes to as well. But if you're creating your own class, you can pretty much add whatever attributes you want. All right, so we've talked about attributes, properties. Next, we're talking about methods or functionality of an object. So here within this robot class, let's just say that there are these robotics laws. So here there are 3 laws of robotics that we're going to just save as a list within the robot class. And this is known as a class variable. And then you also have class methods. So we have print laws and print end law. So here it looks like you're going to print all of the laws, and here you're going to print one of the laws. So the way that you have to use variables that are stored within a class, something to note if you are going to write your own class. Let's say you want to call on this laws of robotics list. You always have to do robot.laws of robotics. So if I run this, it runs fine. But if I do this, and if I try and run this, oops. Oh, right, this one. There we go. It will say that it is not defined. So basically, if you want to use something that is defined within a class, you have to use its class name so it knows where to look for that variable. Just something to note. If I run this again, you can see that the laws are there. So if I have variables that are just defined within the class, so let's say I have, I don't know, robot sound equals, I don't know, whatever it is. If I want to call on that, I have to do robot.robot sound to get that. If I just have robot sound by itself, it's going to be a not defined variable. So that's something to note in terms of syntax of accessing variables that are defined within a class. All right. When you want to use any class method, you kind of have to do the same thing. So similar to how when we're using like different parts of libraries, if we're using, I think, scikit-learn.metrics.mean squared error, in the same way, if you only import scikit-learn, you would have to do metrics.mean squared error, which is why we import mean squared error from scikit-learn.metrics, because they're kind of nested within each other. So in a similar way, if you want to use the print laws method, you got to call on the class to use its method. So therefore, this only works with print laws. If I just want to call print laws by itself, that will not work because that is not defined. That is only defined within the class. So we need to have robot.printLaws. Here, we're just printing the second law because it just takes in any number. Also works with different conditions. If I have law number 9, that doesn't exist. That should be an F string. There we go. There we go. The number 9 law doesn't exist, and it does work for 1, 2, 3. Cool. All right. So now that we have this class of robots defined, remember this is the one with just the 2 methods over here and the laws of robotics there. So let's just say I instantiate Wally to be a robot. Wally has these laws built in as well. So if we do Wally.laws of robotics, he'll have that. And then he will also print, oops, I think it has to take, print the laws. Ooh, okay. So let's have Wally print out these laws. And you can see here that there's an error. So what does the error give us? Take 0 positional arguments, but 1 was given. Now, this is error that we're going to talk about in a little bit, but just know that if you see this kind of error, it is a class error. It says 1 argument was given, but obviously there's no argument given here. So if you ever run into something like this, it's because we have to introduce something known as self. So earlier when we were using print laws out of the class itself, it worked fine. But when we tried to use the method on the object on Wally, it did not work. Kind of similar to when you try and use a method from PD, a method that works out of PD versus working on a data frame. If anyone remembers anything along those lines, like you're doing pd.concat versus df.concat. So that's kind of analogous to what we're doing here. We're using it out of the class versus using it out of an object. And out of an object, this currently doesn't work. We'll see why. All right, so feel free to check out this example over here. But what we have here is introducing self. So if you want a method to be able to work on an object itself, it has to take in an argument of self. So let's just create a brand new robot again, a brand new robot class again. Remember that these were same things that we talked about before, default attributes. And now we have object methods. So object methods are different from class methods because object methods take into account the self. So these, because they don't have an argument self, and self is a keyword when it comes to classes and object-oriented programming. Because these don't have a self argument, these are known as class methods. Whereas these are object methods because we're using self. And we'll sort of see the syntactic difference between those two. So let's say I have this speak method and this add numbers method. And I instantiate this, let me comment this out first. And I instantiate this robot and it has all of these. Now, as you can see here, speak takes in 1 argument. But as you can see here, it says it takes 0 positional arguments, but 1 was given. Automatically, the self will count as the first argument if it's an object method. So therefore, even though it has self over here, if I run this and do wally.speak, it knows how to do that. It knows automatically that self refers to the object itself. So I'm giving it self, the input argument itself here, but I actually don't need to give anything there. So that's how that works. If I want to just set it a name, so wally.name equals to Wally. There we go. It can say I am Wally. And for this, self is always the first argument. That's something that's really important to remember. Self is always the first argument. So if I wanted to just add some numbers, let's say I wanted to add number 0, number 1, this is a pretty straightforward function. When I want to add the numbers, I don't need to give it that first argument. So here, Wally.add numbers is 100, 1. Over here, you can see that worked fine. Got 101. Questions here? Cool. So this, again, showing that you can change an attribute. I can just edit that a little bit to change as well. And also you can use Lambda functions, which not super important for us to know, but in case you are very familiar with Lambda functions and want to use them more, you can do that as well. But yeah, any questions? This is like a really quick breakdown of object-oriented programming. Pretty much throughout this entire time, we've been using objects, object built-in methods, and attributes as well. Pretty much a data frame is an object, and the data frame dot shape, that's an attribute. Data frame dot columns dot index, those are all attributes, and things like dot head, those are methods. Anything with a parentheses at the end. So hopefully this kind of uncovers how a lot of that looks like under the hood. If you were to look up the source code of pandas, a lot of it is defined in classes like this. Again, I do want to reiterate, it's not, data scientists typically do not code in classes, but very, very good to know how a lot of these libraries are structured. If you ever wanted to create your own library, which you can, it would likely be written in classes. But yeah, that's kind of all I had to share for today, object-oriented programming. Any questions or thoughts about this? Cool. I would say feel free to play around with this. It's really more for understanding the structure of libraries that we're using for data science. Scikit-learn has a lot of nested libraries within libraries, so that's kind of how that works as well. But yeah, more good to know. But yeah, over the next 2 days, we're going to get into some pretty heavy math, so get ready for that. I would say if you want to reprioritize, I would prioritize that stuff a little bit more than this, because this, as long as you have an understanding of pretty much, if you can understand methods and attributes and how those relate to what you're coding, I think that's good enough. Right, well, if there are no further questions, don't forget to book your project reviews with me. And I will see you all back here tomorrow. All right, well, bye everybody. Have a good rest of your Tuesday.
Thank you.